Hey 8th graders, today we're starting a new unit on gravity, which is outside of Amplify. So to start this unit, I gave you guys 2 videos to watch for today. The first one is Felix Baumgartner's free fall from outer space. So he went out outside of our atmosphere and basically skydived and then was close enough to Earth where the gravity still pulled on him enough to pull him down. So you guys can watch that, it's kind of cool. The second video is this video on mass and weight. So it says mass versus weight. So a lot of you are probably thinking, what do you mean mass versus weight? There is no difference, okay? Mass and weight are the same things. We just use different units. For weight, we use pounds, and for mass, we use grams. Whereas, yes, we do use different unit. There is a big difference on how mass and weight is calculated and what they are. They're actually not the same thing at all, and if we're looking at numbers, they would definitely change. So that's going to be your explanation today, or your exploration today, is figuring out the difference between mass and weight, and then looking at those calculations to see how those change if we're looking at different planets. So here's your worksheet for today. Your first thing that you guys will have to do is figure out your mass and your weight. Okay, so again, they're not the same thing. So what I have here is this first step tells you guys how to do these calculations. So if you don't already know how much you weigh, you might want to get that from someone, whether you compare with a friend who's a similar size to you, or you guys have a scale at home that you guys can jump on and grab your weight in pounds. So I'll go ahead and do my weight for an example for you guys. So it says first you will need to calculate your mass. So if we step onto a scale, that's measuring our weight, not our mass. Okay, so what mass is the amount of matter that makes up an object, or in the case of my human body, how many atoms and molecules are crammed together to form my human body. Okay, so that's our mass. If I go to a different planet, that doesn't change. Okay, however, weight is dependent on gravity. So if I go to a different planet, that will definitely change. Okay, so for mass, you guys will start out with your weight, and you will take your weight and you will multiply it by 4.4482. So I'm just going to kind of do this example using my weight for you guys. Okay, so if I'm 145 pounds, I'm going to go ahead and multiply that by 4.4482. What this number does is convert my weight in pounds to weight in newtons. So newtons are actually the SI unit, pounds are what we use in America. So I'm going to take 145 times 82. And that's going to be how much newtons I weigh. So 644.99. 644.99 newtons. What you guys see about weight is due to gravity, and gravity is a force. And we're going to learn a little bit more about gravity later. But knowing that gravity is a force, and seeing that we have a unit label of N for newtons, we can remember from our last unit on force and motion that whenever time we were looking at force, we were looking at this unit label of newtons. So because, again, gravity is a force, we're using newtons as a label for our SI unit. Okay, so we've taken 145, which is my weight, multiplied it by 4.4482, and that gives me my weight in newtons. Okay, we're still not in mass though. Okay, so newtons is a measure of weight. So the next step that you'll have to do is convert your weight in newtons into grams. So what we see is, because weight is dependent on our gravity of Earth, okay, if we divide by the number we use to signify Earth's gravitational pull, which is 9.81 meters per second, we call this acceleration due to gravity. Okay, if we divide it by 9.81, that will leave us taking basically gravity out of the equation and just leave us with how much matter goes into our body. So step 2 says take your weight in newtons from above and divide it by 9.81. So I'm going to go ahead, divide 644.99 by 9.81. So divided by 9.81, and we come up with 65.4. You guys can just go to 2 decimals, that's fine. 65.75. So 65.75, and that's in mass. Kilograms is more common to use for the mass of a human body. Grams would be too small of a unit, so we'll use kilograms. So my mass of my body is 65.75 kilograms. Basically, if I were to take all the atoms and molecules in my body and find out their mass and add it together, my mass for my total human body, the amount of matter that fits into my body, is 65.75 kilograms. Okay, so we're going to come back to that number. If we open up our worksheet, okay, anytime you see this column that says mass, okay, so here's mass of my body on Earth, 65.75. Okay, so on Earth, I have a mass of 65.75 kilograms. Okay, what if I go to Mercury? Okay, think about what mass is. Okay, what would my mass be on Mercury? Would it be less than Earth, more than Earth, same amount as Earth? Okay, it's actually the same amount. So if I go to Mercury, I would have a mass of 65.75 kilograms. I haven't lost an arm. I haven't added any body parts. Okay, remember that mass is the amount of matter that makes up my body. Okay, that hasn't changed. Okay, I haven't lost toes or anything. Okay, I am the same person on Earth as I am in Mercury. Okay, so I have the same mass. So anywhere you see this column that has mass at the top of it, you guys are going to write whatever your mass is. Yours is going to be different than mine. Okay, I weigh 142 pounds, so my mass is going to be different than a teenager that maybe weighs 115 pounds. So you will need to calculate your unique mass for this column. If you guys go down to table 2, you'll also see mass right here. So I would plug in my mass for those as well. That category is missing from table 3. Okay, so you'll fill out your mass in this column here and in this column here, and it all should be the same number because you haven't changed how your body is made up or how much matter goes into your body. Okay, let's talk weight then. Okay, so if mass is different than weight, let's talk about what weight is. So like I said in that calculation, your weight depends on mass, or excuse me, on gravity. So on Earth, I weigh 142 pounds, okay? But if I go to Mercury, does Mercury have gravity? Okay, a lot of kids will say, no, there's no gravity in outer space, but that's not true. Actually, there's some places that have more gravity than Earth in outer space. Okay, so if I go to Mercury, we still have gravity, okay? But how much gravity do we have on Mercury? Do we have more than Earth, less than Earth? Okay, because that will affect my weight. So what you'll be using is this first link right here. I'm going to go ahead and split my screens. You're going to be using this first link right here to tell you what your weight on all these other planets and celestial bodies is. So what I'll do is enter your weight here. I'm going to type in 142 pounds, and then I'm going to hit calculate. What that does is it generates all the weights that I would have on all of these different planets. So if I were to go to Mercury, I would only weigh 53.6. That means that I have less of a gravitational force pulling me down to Mercury than I do on Earth. So I'd only weigh 53.6. My body hasn't changed. The amount of gravitational force on me has changed. Okay, Venus, I can see Venus right there. The moon, Mars. If I go to Jupiter, on Jupiter I weigh 358.9 pounds, okay? I gained quite a lot of weight by going to Jupiter. So what does that tell me about the gravity of Jupiter? Is it more than Earth, less than Earth, or the same amount? Okay? So I'm going to go through and I'm going to get my weight on all of these planets. And then also, you guys will see that there's some moons of Jupiter you need to get. So Io, Europa, Ganymede, and Callisto. You have your weight on all of those. And then finally, if you guys scroll down, we have some stars here. So we have the sun, a white dwarf, and a neutron star. So what is your weight on all of those? Okay. For the last one, you're going to be finding the equatorial radius. This is basically the size of this planet. We're just looking at the radius. So from the center of that planet out to one side at the equator of the planet, what is that distance in kilometers? Okay, so for that one, you guys are going to use this second link. If you guys get lost trying to find it, you'll find out where to go in this video. But also it says right here, click on planets and then by the numbers. So you guys are looking for this by the numbers. So your second link looks like this, okay? What you guys will be doing, I'm going to expand this real quick, is up here you'll see planets. You'll also see some moons. So you guys can look, here's the one moon that Earth has, but that's not the only moon in our solar system. You guys can see Mars has 2, Jupiter has almost 80, Saturn 82, Uranus, Neptune, Pluto all have moons. Okay, so the only moons that we were dealing with though were moons of Jupiter. Okay, so let's just take a look first at our planet. So let's find Earth and find out what its equatorial radius is. So if I pull up Earth, the great thing about this is we get a comparison. Okay, so when I click into this data here, you guys will see a comparison of Earth to other ones. So if I scroll down, right below this top header picture, I have this link that says by the numbers. That's where you guys want to be. This gives us all the stats for Earth. So I'll click on by the numbers. And then I have this big data table that tells me all of the information I need to know about Earth. Great thing about this is it also gives you guys a comparison. So you guys can compare Earth to Jupiter in this case. So Earth is on the left, Jupiter's on the right. So I'm going to get a little extra data on this. So I'm going to scroll down until I find equatorial radius. So the equatorial radius of Earth, if I go right here, is, where'd it go? There we go, 6,371.0 kilometers. Okay. Then if I look, I can also get Jupiter out of this as well. So right next to this, we have the equatorial radius of Jupiter, which is 69,911.0 kilometers. Okay, so you guys can see how much bigger Jupiter is to Earth. Okay, great thing about this is you don't have to keep going up to planets. You guys can actually just scroll to the top and there's this drop down menu and you can say, all right, I need data for Mercury now. Scroll down to equatorial radius right here, and you can see that Mercury is only 2,439.7 kilometers as far as its size. Okay, so you guys will need to pull all of your equatorial radii from this website. Again, you can just use this drop-down menu right here to grab your different planets. And then you guys will do the same thing. You guys will go into moons. So you'll need to go back to your main menu up here and then find your moons. So if we're looking at moons of Jupiter, we're obviously going to click on Jupiter. We're going to click on whatever moon we need. So Io in this case. I'm going to go to by the numbers. So scroll down to by the numbers. And then I'm going to find my data in there. And I can also use comparisons here. I need to compare it to, say, Callista. Which one is it? Let's do Ganymede. Oh, there's a lot of moons. All right, so I can compare Io and Ganymede and kind of get a lot of data in that same fell swoop. So if I look, my equatorial radius for Io is on the left. I can say Io has an equatorial radius of 1,821.6 kilometers. And then I can also get Europa, Ganymede, and Callisto by finding them in this drop-down menu. Okay. All right, last but not least, you guys have this table 3. So you guys filled out your weight based on the first link. And then what it says right here is, what is your predicted mass ranking? So I want you to just look back through your data. So we have 2 complete sets of data here. We have my weight on Earth, and then we also know the size of Earth. Then we have our weight on Jupiter, and we also know the size of Jupiter. How do those relate to each other? If our planet gets smaller, what does that do to our weight? If our planet gets bigger, what does that do to our weight? So by looking at your weight here, okay, what is your predicted mass ranking? Which of these 3 things, the sun, white dwarf, and neutron star, is the smallest? And which one is the largest? So rank them 1, 2, and 3. 2 would obviously be your middle one. Okay, finally, you guys have some questions to answer down here. So based on the data you guys have, what patterns do you observe? So basically you're looking at what kinds of patterns you guys have and how you can make predictions with those. So look back through your data. Finally, this question number 3 says, scroll to the bottom of your weight on other worlds. So if I go back to my weight on other worlds, which is my first link, and I scroll to the bottom, you guys have this little reading or this article called What's Going On. So if you read that, you guys will be able to find all your answers for that last section in this little article here. Okay, if you guys have any questions, let me know. But you guys have directions on the sheet in front of you and then obviously in this video. So rewatch if you guys are having a hard time finding your equatorial radius or if you're having a hard time calculating your guys' mass. Okay, I hope you're having a good day and I will talk to you later. Bye.